Yes, now student, I am going to discuss the next topic, isomerism in alcohols. Student, in the chapter of haloalkane and haloarine, I told you that to study the isomerism, one time we have to check how many type of isomerism are there. So we know that there are two type of isomerism. First one is structural isomerism and second one is stereoisomerism. Structural isomerism is further of five types: chain isomerism, position isomerism, metamerism, functional group isomerism, and tautomerism. And the stereoisomerism are of three types. First one is geometrical isomerism, second one optical isomerism, and third one conformational isomerism. Okay. So student, as we have discussed in detail about the type of isomerism, and also we have discussed the definition along with example of all type of structural isomerism. So on the basis of that knowledge, we have to check out of the given isomerism which one will be shown by alcohols. Okay, that is from type of structural isomerism, how many isomerism can be shown by alcohols. This is our the topic. So first one, the alcohol shows chain isomerism. Chain isomerism. What is chain isomerism? Differ carbon main chain. Differ carbon main chain, okay, in two or more compounds. Two or more compounds having same molecular formula. Having same molecular formula. This is called what? Chain isomerism. Now, can we give some example regarding it? So, if we took example of one of the compounds C4H9OH. Okay, so can we draw some structural formula for this one? So yes, in first we can draw what? 4 carbon atom in a chain, and we can attach what? One of the OH here. Okay, we can draw one more. What? 4 carbon atom. Besides of 4 carbon atom, 3 carbon atom in a chain, and one of the carbon atom as substituent. So here we can write OH. Now the name of these two compounds are different. What is it? This one is what? Butane 2 all, butane 1 all, and this one is what? 2-methyl propane 1 all. Student, can we draw one more? Okay, so yes, we can draw one more compound. What? Here the 3, okay, will be no, not possible. Okay, so the 2 isomers of this type of isomerism having this formula is possible. So this is called what? Chain isomerism. Are you getting? Now second one is position isomerism. Position isomerism. Now what is this? Position of functional group. Position of functional group. Which functional group? Here we have to specify the OH. Okay, are differ in 2 or more compounds. Like if again I took the same example, what? C4H9OH. So to show the position isomerism in first compound, I can write 1, 2, 3 and 4. Okay, and I can mention the position here. So again this is what? Butane 1 all. But if I draw one more compound, 1, 2, 3 and 4. Okay, and I draw OH in other carbon atom of main chain, then it become what? Butane 2-ol. Butane 2-ol. Isn't it? So this is called what? Position isomerism. And this is called what? Chain isomerism. Getting? Student, can we show one more type of isomerism? By observing the definition of different type of isomerism. So student, we have one more isomerism. This isomerism is known as functional group isomerism. Functional group isomerism. Now what is functional group isomerism? Two compounds, okay, have two compounds with different functional group. Different functional group. Here the functional group are different. Functional group, but have same formula. Okay, student, to select or to find this type of isomerism, we have to search such two compounds which are made up of same type of atoms and also having single bond. So same type of atoms, like suppose we say C, H and O. These three atoms containing and single bond and what? Single bond. Okay, containing compounds that is, you can say what? Functional group. Okay, or what? Alcohols and what? Ether. Okay, student, in alcohol as well as in ether, these three atoms are present, C, H and O, and also they are having what? Single bond. So there are two functional group which consist C, H and O. Okay, and also they are having single bond. Student, now you can think about aldehydes. It also consists C, H and O, but remember there must be one double bond, so we cannot consider it. You know about ketone. Getting? It also made up of C, H and O, but again ketone have double bond, so again we cannot consider it. One more functional group, carboxylic acid. It is also made up of C, H and O, but remember there is a double bond. Isn't it? So again the carboxylic acid cannot be considered in the functional group isomerism with alcohol. So we can consider only two functional group. This I told you that we have to apply our intelligence. Getting? So now think about two compounds. Compound number 1. This is CH3O, and again this is what? CH3. Isn't it? And now let me write one more compound. What? CH3, CH2, O and H. So again you can search in two compounds. They consist same number of atoms and their molecular formula. Now what? Molecular formula is 1 and 1, 2 carbon. So C2. Hydrogen is how many? 3 and 3, 6. So C2H6 and single O. So C2H6O. Here count 2 carbon, 1, 2, 3, 4, 5 and 6 hydrogen and 1 O. That means what? Alcohols can show isomerism with what? Ether. Isn't it? Student, in the content of ether, again we can apply this type of isomerism. So alcohol, okay, out of structural isomerism, that is 5 type of isomerism, especially shows 3 isomerism, 1, 2 and 3 type of isomerism. Even the tautomerism is also shown by the alcohol. Tautomerism means what? Oscillation of one of the atom within a molecule. So this will be for your homework. Okay, you have to search example of tautomerism. Student, on the basis of it, you can solve some questions. Like question number 1. Write all possible isomers of what? C5H11, okay, O. C5H11O. But if I write it, okay, it's okay. C5H11 and I am writing here what? OH. C5H11OH. So you have to write all possible isomerism. How many isomers are possible with this formula? For this, what you have to do? You have to start mentioning by chain isomerism, position isomerism, and also functional group isomerism. Are you getting? So search for the question. Yes, student, next one, method of preparation of alcohols. Student, this is very big topic. It require at least 2 periods. Okay, so as many methods of preparation possible I am explaining. Okay, now we can help. Okay, the chapter first, there is some of the reactions are there to which we can prepare what? Alcohols. So which are these reactions? First one, by the reaction of alkyl halide. Okay, alkyl halide means what? RX with aqueous alkali. Now in aqueous alkali you can consider many things, like you can consider NaOH, you can consider what? KOH. But the most important thing is what? It must be aqueous solution of alkali. This is called what? Aqueous alkali. So by the reaction of alkyl halide with aqueous alkali, we have checked this reaction when RX is heated with aqueous KOH, the nucleophilic substitution reaction, okay, takes place very easily and it forms what? ROH plus KX. Okay, even we have seen the comparative study of this reaction between these two species. If we convert it like C2H5Cl plus aqueous, remember it must be aqueous, okay, aqueous KOH, then it forms C2H5OH plus KCl, isn't it? This is one of the reaction. But the limitation is there of this reaction. And what is the limitation? Okay, can prepare 1 degree and 2 degree alcohols easily. And in pure form. Pure form. Okay. Preparation of 3 degree is difficult. Why? Because now some quantity of alkene is also obtained along with the product of alcohol. So there is the problem of separation of the alcohols by the alkene. Therefore there is a limitation. Okay, next one, by the reduction of carbonyl compounds. Do you know about carbonyl compounds? Which compounds are called carbonyl compounds? Which are having C double bond O functional group. Okay, that is what? That is two compounds are there which belongs to carbonyl compounds. These are what? Aldehydes and what? Ketones. They consist what? Carbonyl carbon, isn't it? Or carbonyl functional group. So aldehydes and ketones. Student, there is a very simple phenomenon. What is this? Which you have to learn. Alcohols. Okay. On oxidation forms carbonyl compound, which on further oxidation forms what? C double bond O OH, this compound. Okay, that is what? Carboxylic acid. Means alcohols converts into aldehydes and ketone, which on further oxidation converts into what? Carboxylic acid, isn't it? Now the similar thing, if we reverse the reaction, carboxylic acid on reduction can give what? Carbonyl compound, that is aldehydes or ketone, which on further reduction gives what? Alcohols. So by taking the help of this knowledge, we can proceed the reaction as number 1, when aldehydes or ketones are reduced. Now student, for reduction we need what? Reducing agent. In the presence of some specific reducing agent. Now can you tell me the name of some specific reducing agent? Okay, you have to learn it. What? Like lithium, aluminum tetrahydride. Okay, next one is what? H2, Ni, okay, Pt, like what? Catalyst. So these are called what? Reducing agent. So now I told you aldehydes and ketones can be reduced using this reducing agent, specific reducing agent, and forms different type of alcohols. That is what? 1 degree alcohol and what? 2 degree alcohol. So now I am writing reaction with aldehyde. Okay, like R, okay, C double bond O, and this is what? H. When reduced, okay, using what? This reducing agent, now it converts into RCH2, okay, OH. That is simply what? The 2 hydrogen is added to the compound. This is known as what? 1 degree alcohol. 1 degree alcohol. Now can you write reaction with some specific compound like CH3, C double bond O, and this is H. On reduction gives CH3, CH2 and OH. That is, you can say acetaldehyde forms ethanol. Okay, but think about if we change the carbonyl compound, okay, by what? Ketone. By what? Ketone forms secondary alcohol. Okay, now there is no primary, there is what? Secondary alcohol. So now we have to change ketone. R, C double bond O, R, okay, plus H2 in the presence of this specific what? Reducing agent forms R, C, this is R, okay, and now this is CH2 and what? OH. Okay, that is RRCHOH, that is it gives secondary alcohol. So this is the difference between the aldehydes and ketones. So in this way we can also distinguish aldehydes by ketones, that the aldehyde gives primary alcohol on reduction. Okay, let me write here what? On reduction, while the ketone on reduction gives secondary alcohol. So these are two important reactions. First one what? By the reaction of alkyl halide, that is RX, with aqueous alkali. Remember aqueous alkali, that is it must be strong NaOH or KOH. So RX plus aqueous KOH gives alcohol. You can change the R by what? C2H5. So with KOH, which one? Aqueous, it forms ethanol. You can write name also, ethanol plus KCl. Limitation is there. What is the limitation? Limitation, the primary and secondary alcohol can be prepared easily in pure form. Okay, because there will be only one product, what? ROH. But in case of tertiary alcohol, that is preparation of tertiary alcohol, so we have to take what? Tertiary alkyl halide. In this case, it undergoes what? Dehydrohalogenation also little sometime, and thus along with alcohol the alkene is also getting forms. Okay, next one is by the reduction of carbonyl compound. Now the carbonyl compound are represented by this functional group, that is C double bond O. So belonging to this C double bond O, we have two compounds, what? Aldehydes and ketones. We have a general knowledge which we learned from 11th class. Alcohols on oxidation gives carbonyl compound, which on further oxidation gives carboxylic acid. So if we see its reverse reaction, the carboxylic acid, when applying specific reducing agent, will reduce to carbonyl compound, and the carbonyl compound on further reduction gives alcohol. So taking the help, we have to prepare what? Alcohol. So we can select what? We can select carbonyl compound. So the carbonyl compound belongs to two things, aldehydes and ketone, which on reduction gives different product. Now, can we directly reduce carboxylic acid? Yes, we can directly reduce carboxylic acid, but here we have to use a strong reducing agent like NaBH4 or LiAlH4. So this is for your homework. That is, you have to write reaction for the reduction of carboxylic acid directly into what? Alcohol. Yes, student. Now this is the most important preparation of alcohols. That is what? Industrial preparation. That is how in the industries level we are preparing alcohol. Student, you know one of the things that we require lot of alcohols per day, because alcohol is one of the very versatile compound which has very high significance in all sort of life, and therefore its preparation requires some specific method to rapid and to produce a huge amount. Okay, in this preparation the first one is from alkenes. From alkenes, that is, alkenes means what? Alkenes means compound containing what? Double bond. From alkenes. Getting? This is the major source of the preparation of the alcohol. Student, this is also very important in the form of the question is asked in the CBSE board with the mechanism. So first I am writing what? It's a reaction. When alkenes is hydrolyzed, okay, in the presence of catalyst what? Dilute H2SO4. Remember, here we have to take what? Dilute H2SO4, not concentrated. or we can write, we can use weak acid H3PO3. Okay, it forms alcohols. It forms alcohols followed by Marconi Cauchy rule. This is very important. What? Marconi Cauchy rule. Isn't it? We have checked these Marconi Cauchy rules in our previous chapter, haloalkane. Okay? So, when alkene is hydrolyzed in the presence of dilute H2SO4 or weaker acid like H3PO3, it forms what? Alcohols followed by Marconi Cauchy rule. Therefore, this reaction is known as acidified. Acidified. Why acidified? Because the catalyst used is what? Acid. Acidified. Now, hydration. Acidified hydration of alkenes. So, in the exam, it is asked by this topic that explain the acidified hydration of alkenes. Any particular alkenes can be given. Okay. This time I am using very simple alkene. Very simple alkene. Okay. Like by ethene. This is the first member of alkene. So I am directly writing the reaction because already reaction is given here. What? When C2H2, that is what? Ethene. Okay. And is hydrolyzed HOH using what? Acid catalyst. Remember, student, again it must be dilute. Okay. Why dilute? I will explain. It forms CH3 and the OH attach here. This is OH and there will be what? One of the H. This H. This is called what? Addition reaction. Why this is called addition reaction? Because simply addition of water takes place in the ethene. Ethene is double bond containing compound. We know that the double bond containing compound easily gives addition reaction. So this reaction also the example of addition reaction. Getting? Now here we obtain what? Ethanol. Ethanol. But student, the most important thing is what? Mechanism. Okay. In the mechanism, student, you know that water is not so reactive. Isn't it? So to make it reactive, we used what? Catalyst. What? Acid. So in first step, protonation of water, okay, takes place. Protonation of water takes place. How it is? O, H and H. Student, whenever we have to show mechanism, we must have to show its proper structure. Plus H cation. It is obtained from dilute acid. Now what is H cation? It is exactly 2 electron deficient, while the water has 2 lone pair electron. So one of the lone pair electron is donated to hydrogen cation. Thus the protonation of water takes place and the formation of hydronium ion takes place. This is what? Hydronium ion. Now one of the lone pair is donated, therefore there will be only one lone pair. Being the electron pair is donated, therefore the hydronium ion has what? Positive charge. Now second step, attack of hydronium ion. Why? The hydronium ion is what? Electron deficient species and highly reactive species. So these hydronium ion attacks on alcohol. So attack of hydronium ion on alcohol, isn't it? Now, sorry, on what? Alkene. We are watching the preparation of alcohol. On what? Alkene. Now, what is alkene? So we are using here what? Ethene at that time particularly, plus HO, this is H, and this is one more H, and there is what? One lone pair with what? Positive charge. That means there is electron deficiency. So the electron pair, this electron pair, this is H, this electron pair is again gained by oxygen, okay, and the electron, pi electron pair is shifted, okay, to adjacent carbon atom. When the hydronium ion attack on alkene, the pi electron pair gets shifted. By shifting pi electron pair, now the carbon and carbon, there will be only single bond, and now the minus charge come here. So in this minus charge, the H can attack easily. So here the attack of H takes place. Now the electron pair is shifted, okay, from this carbon to this carbon atom. That means the carbon atom, terminal carbon atom becomes electron efficient. So it acquires what? Positive charge. Means what? Here formation of carb cation takes place. Formation of carb cation takes place. Carb cation takes place. Student, if I specified alkene by what? Ethene, okay, then there is no option. There will be only one carb cation will form, which is what? 1 degree carb cation. There is no option at all. So this is become our reaction intermediate. Reaction intermediate. That means the reaction proceed by the formation of carb cation. In case of ethene, this is what? Ethene. There is no option. There is no chances that two different type of carb cation will form. If we took different type of alkene, then there may be chances, but this time there is no chances. Now third step, okay, in third step, nucleophilic attack of water takes place on what? Carb cation. On carb cation. Student, in the previous step, here the H attacks in this carbon atom. That means what? That means the water molecule is eliminated from here. So this water molecule in the next step participate in the reaction and act as nucleophile. Why? Because the carb cation, this carb cation can act as what? Electrophile. So on electrophile or on carb cation, the nucleophile means water will attack. How it is? So this is what? Ethyl carb cation. What is ethyl carb cation? 2 electron deficient plus what? Water. This water has 2 lone pair, okay, therefore it acts as nucleophile. So now the electrophile will attack on this carb cation, forming, okay, one of the intermediate, which is what? Highly unstable. Now here the O is attached, okay, and now there is what? It's H, and there is its H, but there will be only one lone pair, okay, and one lone pair, therefore it acquires with charge? Positive charge, isn't it? So this intermediate form, which on fourth step, okay, due to lack of space I am writing here, fourth step, what? Deprotonation takes place. Minus H cation, I am showing in the form of minus H cation. Means what? There is a bond between H and O. This oxygen is electron deficient, so one of the bond pair Okay, due to more electronegativity of oxygen is gained again by what? Oxygen. Thus, there will be final product CH3, CH2 and what? OH. This is the final product. Plus, there is what? H cation. The H cation in very earlier step we used as catalyst. So now it will again get regenerated and will catalyze the next molecule of ethene. So this is about the reaction and reaction mechanism. Student, I told you this is the most important reaction. What? From alkenes. Alkenes can be denoted by C double bond C. Okay, I am not writing anything here. You can change any of the compound here. The reaction is when alkene is hydrolyzed in the presence of dilute H2SO4. Student, I told you we have to use dilute H2SO4. Why? Because student, here the formation of alcohol takes place. If we use concentrated H2SO4, then what will happen? You know that the concentration H2SO4 act as dehydrating agent. Means what? It can eliminate or reduce the water molecule from the ethanol. That means what? The reaction will proceed to backward direction. That means it will be equilibrium reaction in case of what? Concentrated H2SO4 is used. Because concentrated H2SO4 act as strong dehydrating agent. Therefore, we are using dilute H2SO4 or H3PO3. That is, we require only H cation to catalyze the alkene. Okay, so that we can obtain only ethanol. Now, in the mechanism, the first step, what is the first step? Protonation of water. That is acid which liberates H cation. Okay, it is gained by water. This is called what? Protonation. So protonation of water takes place, formation of hydronium ion. Hydronium ion. This hydronium ion is highly unstable and highly reactive. Therefore, in the second step, this hydronium ion attacks on alkene. Alkene is specified by me. What? This is simply what? Ethene. So if I took ethene, okay, then there will be formation of carbocation takes place, but there will be no option. Only one carbocation will form, which is what? Primary carbocation. If I took different type of alkene, then there may be chances of formation of more than one type of carbocation. We will see in the next class. Now, the third step, the water releases from the second step will act as nucleophile, and this nucleophile, that is the water, okay, will attack on carbocation. So, will form again one of the highly reactive species which is highly unstable. So, in by this unstable species, one of the hydrogen will release in the form of H cation, and thus formation of ethanol takes place. This step is known as protonation. Deprotonation means releasing of proton. That is called deprotonation, and the process so called deprotonation process. Okay, we will check some bigger or higher alkene in next class.